Good morning, good afternoon, good evening to you, and welcome to Unit 7, Lesson 4. Unit 7, Lesson 4, we are taking a look at the distance between 2 points. We're going to find the distance between 2 points, looking at a graph, and then trying to decide what that third side is. So, a couple steps when we can do this. Let's get into it. First step you want to do is you want to plot the points that you are given. Sometimes they'll be already given to you, but if not, you want to plot those points. Then you want to draw a right triangle to connect the points. Draw that right triangle, connect those points. Then you want to find the change in x values and find the change in y values. Sometimes we denote that as change in x. I know it looks like triangle. That's really a delta, and then change in y. Then finally, we want to use the Pythagorean theorem to find the distance of the hypotenuse. Hypotenuse. Okay. Couple steps there. Plot your points, create a right triangle, find the change in x, find the change in y, use the Pythagorean theorem to find the distance of the hypotenuse. So here's our first problem. We got 2 points here. They're already plotted for us, which is nice. One is at 5, -2. The other one is at -3, 4. So what we want to do here is we want to make a right triangle. So this looks like, since it is the diagonal, that looks like a hypotenuse. And notice we're trying to figure out the distance between this point and this point. Kind of hard to count because you go through quarter boxes, fractional boxes, that kind of thing. So we create a right triangle. You go here, and you go here. Okay, so we drew our right triangle. We know it's right because we went straight down and straight over. Okay. Next, you want to do is you want to count your change. Change in x is our left and right. So from this point to this point, this is always going to be a positive number because we're kind of counting the distance between one thing or another. Again, we can't have a negative distance. So we're going to say from here is 1, 2, 3, 4, 5, 6, 7, and 8. So our distance for this problem is 8 units for the change in x. And I can move that over here. Change in x equals 8. Let's check our change in y. 1, 2, 3, 4, 5, 6. So that would be 6 units. Now you are in a situation where you have 2 legs and a missing hypotenuse. So going back to our, I should put this over here too, change in y. Okay, we found the change in x, we found the change in y. Now we're going to use the Pythagorean theorem to find the distance of the hypotenuse. Okay, remember the Pythagorean theorem says a squared plus b squared equals c squared. Since we know it's a right triangle, we know that that is going to be the case. Okay, so a is just substitution, 8 squared, plus b, which is 6 squared, and that should equal c squared. If you're going with our standard, we're going to say 64 plus 36 equals c squared, which is 100, which equals c squared. And we continue on by taking the square root of both sides. And we get c equals 10 units. If you decided to start right away by taking the square root, again, you can do that. Let's show it on our calculator. If we want to start by taking the square root, we can get 8 squared plus 6 squared, and we're taking the square root of that, and that's going to equal 10, which is our answer. It's our shortcut route. Great job. And that's it. That's all you do. Plot your points, create a right triangle, find the change in x and the change in y, and then use the Pythagorean theorem to find the hypotenuse. Good. Coming back for page 2 of our notes. If you have any questions, let me know, and I will reach out to you as soon as possible. Thanks so much. Have a great day.